Hi, welcome to the Shiko Mathematics Statistic Problem Solving Sessions. So today we're going to continue to look on the sufficient statistics. And so for today's problem, we have an independent random sample from the uniform distributions and from the 0 to theta here. So we want to take a look at two things here. The first, we want to find the sufficient statistics for theta. And then we also want to find it. After we find this sufficient statistic, we want to show it is a minimal sufficient statistics here. All right, so let's go ahead and let's start and go to our whiteboard here. Okay, so the first thing is here from our previous video, we know, okay, so here this is my density function fx theta equal to the 1 over theta and the x from the 0 to what? To the theta here, right? So the first task here, we want to show this is a sufficient statistics. So by the Fisher-Newman factorization series, we know in order to show that, that's the theory we're going to use. Okay, so the first, let's go ahead and start here. So we find our likelihood function. So the likelihood functions here, this will be 1 over theta to the nth powers, right? So then we have like the x1 theta and the times the 0, the identity functions, x2 theta, and the to the I to the 0 to the xn theta. Just like we did for our previous, the video, how to find the sufficient statistics. Okay, so now this one's here, we can rewrite this is theta n. That means we can change this, we can say this is x1, x2, we change it to the order statistics. That means we know the smallest order x1 has to be greater than 0. Right? And then my largest order statistic xn here. So I put x parenthesis n. So what is this one? This one has to be less than theta. Okay, so now if we kind of rearrange this a little bit, so I will put this is 1 over theta n, then this is I to the xn, order statistic xn, so theta, then this is identity for the 0 x1 here. So by the Fisher-Newman factorization theory, so I know this is what? This part, this will be my g theta, right? So it's a function of the theta and the test statistics is a statistics here. And then this part here, this is my h of x here is only depends on the x. So from the Fisher-Newman factorization, so I know what is my sufficient statistics. So the sufficient statistics for the thetas here is what? So we know the sufficient statistic for the theta by the Fisher-Newman factorization, we know it's what? It's the x to the n. So it's the nth order statistics here. Okay, so after we finish the first task, we're going to take a look at the second task. How do I show this one's here is minimum sufficient statistics here? So, okay, so let's kind of refresh our memory. So in order to show minimal statistics, we are using Lemon-Sheffield series here. So what do we say is here? So let's say you are consider a likelihood function. So you are consider a likelihood functions of the x to the theta. here. And then we can choose particular x equal to some x zeros here, such that, so if the likelihood function of the theta over the likelihood function of the x0 theta, if the ratio of these two likelihood function is independent, okay, so it's independent, so this one here is independent of the theta here. Okay, so now this will be our, then the x, so whatever we find, these ones will be our minimal sufficient statistics here. Okay, so now let's go ahead and start with here. We find our sufficient statistic is the x to the order statistic n. So here this is x right better, right? So this is xn here. All right, so we know the x is sufficient. Now I want to show this is a minimal sufficiency here. Okay, so by using the Lemon and the Sheffield theory, okay, so let's go ahead and find the x to likelihood of the theta and the likelihood of the x0 thetas here. Okay, so by the likelihood function we just did here, right? So we can do here, so for the thetas here, this is 1 over theta n, then this is I, so this is xn is less than theta, then times I, then this is the 0 less than x1, right? So it's the first order statistics here. Okay, so now let's take a look at here. So for the x0, I have 1 over theta n. So the I function, so this is x0 to the nth order statistic less than theta, and the times this is the 0. Okay, so this is the 0 greater than x0 to the first order statistics. All right, let me write this a little clearer. So this is the first order statistics here. Okay, so let's take a look here. My sigma n can cancel here, right? So now I have this one's 0 greater than, less than x the first order, and this is x0. So after I cancel this one out here, okay? So in order for this ratio to be independent of the theta, right? So in here, for these ratios here, in order to be independent of theta, what do we need to do? See here, we have to let the nth order of the statistics here has to be equal to x0 to the nth order statistics. All right. So that's why, because then because in here, if they are equal, then you can cancel, you can cancel this one out also, right? Then that's why it's independent of theta. So in order to be independent, so I know my nth order statistic has to be, the equal to the x0s to the n's here. All right. So that's why we know okay, so that's why we know the xn is not only a sufficient statistic, xn also is a minimal sufficient estimator statistics for what? For thetas here. All right, so like for this problem, we used the two theories to do it. First, we used the Fisher-Riemann factorization theory to show, to show that xn is a sufficient statistic. And then in order to show it's minimal sufficient. What you need to do, now we need to use the Lemon and the Sheffield theories here. So try to show this is independent. So we have to independent of the theta. So that's why we have to prove. So we know that x to the nth order equal to x0 to the nth order. So that's why I know xn is a minimized sufficient statistic for the parameter theta. All right, that's it. And nice to talk to you about this problem. And so our next video, we will take a look at some other sufficient statistic problem and see some interesting ones. And okay, nice talk to you and looking forward to talk to you in our next problems here. Okay, bye-bye. Have a good day.